So let's just check this before we start. We are just going to write down, the condition for analytic function. This function should also be analytic, so that we are actually going to use the whatever Laplace equation we're going to check. So del u del x is equal to del v del y, something which we have already seen. And what we can do for this is we can actually differentiate, okay, with respect to x. We're going to do it on both sides. Okay, we're going to do it on both sides. So I will just differentiate it with respect to x. So it will be del square u del x square. So I'm just going to take up del x on both sides. Okay, and on this side it would be nothing but del square v, and this would be del x del y. Okay, so we have got this expression, and let's just mark this as 1. And the second condition for function being analytic is, del u del y is equal to minus of del v del x. Here also we can actually do the same thing, but this time we are going to differentiate it with respect to y. Differentiate with respect to y. If we do that, we can actually get this as del u del y square. Okay, sorry, del square u del y square is equal to minus del square v divided by del x del y. Same thing, right? And this will mark it as 2. So now if we just add up 1 plus 2, okay, we're going to get this Laplace equation. Del square u del x square plus del square u del y square is equal to 0, right? This is the same term on the right hand side when there is a minus sign. So this is actually the Laplace equation. So, if we are just given a value of u and not a value of v, and you want to show that this function is analytic, you can use a Laplace equation, and if it satisfies Laplace equation, this is basically more or less analytic. Okay, this is your Laplace equation. Okay, so what we can do is we can probably take up an example, as we always do, to understand it better. Okay, let's take one. So a typical example might be, before we start, we should know that f of z is equal to u plus iv. So in order to define the entire function, you should know what is the form of u and what is the form of v. The question is, if we know u, let's say u is equal to x square minus y square, can we find v? Turns out we can. Okay, if it's an analytic function, we can. Okay, but first, before we do that, we have to check whether it satisfies Laplace equation or not, and whether this is basically analytic or not. Okay, so for that, it's very simple now. Del u del x is equal to 2x. That means del square u del x square. So this is u, my function. So I'll take del x of x square minus y square is 2x, and del x of del u del x is nothing but del x of 2x is equal to 2, right? And then I can take del u del y is equal to minus of 2y, right? And del square u del y square is equal to minus 2. So this is, minus 2. So this is plus 2, this is minus 2. You add them up, you get 0. That means it satisfies Laplace equation, right? So you can say del square u del x square plus del square u del y square is equal to 0, right? Is equal to 0, and you can conclude that it satisfies Laplace equation. Once it satisfies Laplace equation, you can actually also find out what is the value of v. We are going to just take up, the typical idea of differentiation here. Okay, then we are going to find out. So we know dv. Okay, and dv also is also a function of x and y. So it can be written as, del v del x dx plus del v y dy. And then we can actually use, okay, we already know. Del u del x is this, u del y is this. Okay, maybe I can just mark this. I'm not going to rewrite this again. So this is our condition for a function to be analytic. We're going to use this condition here. Okay, so del v del x, del v del x is minus del u del y. So we can replace it with minus of del u del y into dx. Please don't mix up. Please make sure that you understand this. Plus del v del y, and what is my del v del y is del u del x. So I can write it down as del u del x. And I hope to understand the intention behind writing this way, because you can find out del u del x, del u del y, del v del x, and del u del square u del x square, and so on. So you already know, so easily you can do it, and you can write down v into w and find out what's the form of that function. So this is simple. So we can do this now. It's very simple now. We can just take dv is equal to, now del u del y. Del u del y is minus of 2y. You've seen. So I can just write it down as plus of 2y, minus minus is plus. So it is 2y dx plus del u del x. Del u del x is x. So I can write it down as 2x dy. And this is actually a standard form of differentiation. What you can do is we can actually take out common, and then within bracket it will be y dx plus x dy. Okay. So I'm not going to jump here. I'm just going to show you something which you might already know. Maybe here. Let's sit down this way. If I write down d of xy, okay, I can actually, there are two parts here, okay, so I can just write it down as, d dx of xy into dx, right? And if you do it in general, dx gets cancelled, it means d dx. So this would be y dx, right? In a similar way, I can also write down as d dy of xy into dy, and this will be nothing but d dy of y. This is x dy. Okay, so here also it's the same, y dx plus x dy. Okay, y dx plus x dy. So what you can do is, if you just combine both of them, y dx plus x dy. Okay, so y dx plus x dy, you can combine y dx plus x dy. Okay, it can be written as d of xy. You combine them, and that both are variable. Okay, so in that way you can actually make things much more simpler. That means what I can do is, I want v, I don't want dv. That means I'll integrate it. So I integrate dv, and then I will integrate on this side. So 2 is there, 1, and then I can integrate d of xy plus c. See this, if you expand this, you're going to get y plus x dy, okay, based on this idea. Okay, here I'm just taking it that x is constant and y is constant, that I'm showing it separately. But if both x and y are variables, you have to differentiate by parts, right? And then you add this, you get this dxy plus c, right? You get integration here, and then it means that you can simply write down what is my v. V is equal to, integrate this, you integrate d of xy, it will be just xy, so it will be 2 times of xy plus c. So this c will be there, don't worry, this is just a constant of proportionality. Okay, we are going to just leave it that way only, doesn't matter. So v is equal to 2xy plus. So this is how you find out v if you are just having the value of u. Okay, and in this way you are going to get a lot of problems. Okay, you can get typical problems, and that will be important. Okay, a typical question that might be asked is this. Okay, yeah, typical question might be something like this, and it will be part of a district question depending on what kind of problem is given. Okay, now prove that, okay, the following function is Laplace equation, okay, and find its, okay, and find its harmonic conjugate. So if you are given the value of u, you're going to find out the value of v. If you are given the value of v, you are supposed to find out the value of u. You can do both ways, okay? You can do it both ways, okay? And let's take one example. Let's take one example here. Or this will be a typical question that might be there, okay? And when you do it entrance exam, there are shortcuts. You can easily do it. But for typical university exam, you basically need to do it in detail. Let's say this is 3x square y minus y cubed. So this is v, which is when you're supposed to find out the harmonic conjugate. That means you're supposed to find out u. Okay. So what we do is we just find out what is del v del x, because the first part of the question is it satisfies Laplace equation. So you can do it on your own also, and just do it here. V del x, x is only this, so that means this is 6 xy. Right. And then we can find out what is del square v del x square. Okay, this is nothing but 6y. And then we have del v del y equal to 3x square minus, this is 3 again, y square, right? And then del v square v del y square, double differentiation, would be minus of 6y, right? So you got this, and then just add them up, okay? If it is valid for u, the Laplace equation is also valid for v. So del square v del x square plus del square v del y square. Okay? So 6y minus 6y, so it is 0. So that means it satisfies the Laplace equation. We can say that this is basically nothing harmonic in nature, okay? So it's basically a harmonic. So that means if it's harmonic, that means its harmonic conjugate should also exist. Okay. So if we say its harmonic conjugate exists, we can just simply do it in this way. Du is equal to del u del x dx plus del u del y dy. Okay. And I don't know u, I know v, so I'll just replace everything with v. So del v del x is del v del y dx minus del u del y is minus of del v del x dy. So more you practice, everything will come to you naturally. You are not going to waste much time here. Del v del y here. So this is 3x square minus 3y square dx minus del v del x. So del v del x is 6 again. I'll just take it to be 6xy dy. Okay. And then you can take all the x terms together and y terms together so that it becomes a bit easy. So I can just take it to be 3x square dx separate minus, I can take 3 common. Here I will take y square dx plus, now this one has a mix of x and y. I've already taken up the minus sign outside, so I'll put a plus, and this will be 2 times of xy dy. Now what I want u, so I have to integrate it. So that means this will be du is equal to 3 times x square dx minus 3 times integration. Now look here, if this is x, okay, and there is a y square, there is no x term, you can simply write it down. You'll eventually see that this is correct, okay? This you can write down y square. This is y, so you have got a y here, okay? You can ignore the constant here. You have y here, remove this, you just put x here. This is a trick to do it, okay? And then t. Let's see. Now expand this. Think about this now. You are expanding t of x y squared. Okay, let me just do it once. I think it's better to do it. So one is constants, I can take out x, and then I can simply write it as d of y squared. And then I can take out y square, then I can write it down as d of x, right? So here I can write it down as x, and then d dy of y square into dy, okay, plus y square. Here I don't need to do anything, I can just keep it as dx. So y square dx is already there. And then this is x, this is d dy, y square is 2 times of y, so it is 2xy dy plus y square x. See, this is the same
So
thing.
the result will be x cube minus 3y square x plus c.
Right, yeah, absolutely. So that means if you do it, you integrate it, this would be x cubed, because if you integrate it, this is x cubed by 3, 3 gets cancelled, so it is x cubed minus, this becomes easy, 3, and integrate d times of xy square, so this is 3xy square. So you know, this is a typical integration problem, and this is a typical way of combining two terms. It's basically a harmonic function. You know, most of the time you see that these terms get combined, okay, and this is the easiest way to do it. Plus C. That's your answer, okay. So in exam, when you do it, what I'm interested in is actually to see the value of u, the steps that you are using to do the calculation, and also you prove that it actually satisfies Laplace equation. Just to show Laplace equation satisfaction, maybe 2 marks, even 1 mark is okay, because this is very short, okay. But harmonic conjugate depends on the complication of the problem. If it's a typical problem, these kind of problem, it may be around 2 to 3 marks, not beyond that. But then if you are giving a more complicated problem, a bit more mark may be added. Okay, so please make sure that you understand this and you understand these steps. Okay, these steps are there which are not typically used in integration, but then this is something which you need every now and then in this particular chapter, complex. Okay, let me give you one question now, which you can do it on your own. Okay, and let's see if you can do it. Okay, so let me take one more example. It's the same. You have to find out whether it satisfies the Laplace equation or not, and also find out its harmonic conjugate. But this time I'm giving you u, I'm not giving you v. So u is equal to x cubed minus 3xy squared plus 3x squared minus 3y squared plus 2x plus 1. That's it. So you have to show whether it satisfies Laplace equation or not. This is probably the easiest thing to do, okay, in this unit. And then you have to find out what is v. So you do it and tell me what is the form of v.